and gentlemen, welcome back to another live stream. So this is part 3 of this stream. Okay, the connection is back. Great, cool. Alright, so I'm gonna just share the stream on my Discord. You can join my Discord, link down in the description below. Live. So this is part 3, I believe, yeah. Where we're basically working with the AI, Odin, and SDL3 with SDL3 GPU, obviously, and yeah, and the open code for the AI agent. Alright, so this is what we got so far in the last stream. I just got this little chunk being rendered right here with the camera, and I could basically switch the wireframe mode with F, and obviously the cube just got a little texture there, but yeah. And the interfaces are also being called, as you can see, which is nice. But anyway, now let me just grab this chat right here, pop out the chat, and let's go. Alright, so that works. So let's just launch up open code and let's see what we can do. Open code. Oh, but it wouldn't allow me here, so yeah, fine. Let's just open code here, but let's go inside of the projects folder first, and SDL GPU Odin, and open code, and let's go. So read the code base. Let's see. So what we're gonna work on today? We're gonna work on, let's maybe start with destroying blocks and placing blocks. Code base read. Here's the summary. A small SDL3 GPU render framework plus voxel demo ran in Odin. There you go. Parametric structs. Alright, so we're just gonna tell it to so what do you suggest we do next? Let's see what it's gonna say, and then go from there. Alright. Post-processing pipeline. All the shaders already exist. Bloom, tone map, but nothing used. Oh yeah, actually let's add the sky. That would be cool. We already have the shaders for that, I think, too. But yeah, the chunk is hard-coded to 1. Add chunk storage by position generation across chunks and frustum calling. Alright, or textured colored voxels. Right now every block uses 1 flat added texture atlas per face UVs per block color. Skybox shaders exist. Normal based directional shading would make the terrain read much better. Nice greedy meshing perf. The current mesh builder creates 4 birds plus 6 indices per exposed face. Would cut okay, which direction interests you most? Since it unlocks everything else, but is the fastest win. What should we build next? I mean, fine, let's go with the skybox. Make a cube map skybox. You can find the C example in the parent directory. Let's go. Is the stream fine? Yeah, it seems like it. Cool. Now let me read the existing skybox shaders in this project. Let me check SDL3 vendor bindings for cube map related structs functions and images available. Let me find. In fact, like SDL3 also supports image decoding too for some few things like BNG in latest versions. So I'm not sure how they differ, like which one is better, the Odin one or the SDL one. In fact, same thing, same question I have with file loading and stuff. So I guess I'll have to research about that later. So it's reading common the odin RGB pixel thumbnail. Right. Thinking. So we don't got anything crazy so far, so like we just got like a build chunk mesh function which takes in a dynamic array of vertices and indices, and you know, like a chunk pointer which basically it writes to. The chunk here is just like blocks, which is like a 3D array essentially of grid size boolean. So currently it's just binary, there's no block types just yet. We can add that later. So as it's already available, add a layer field, pass it through in upload. So it's gonna basically make a texture of 6 layers for all the 6 faces it needs for the cube map of the sky. So binding structure already has layer, defaults to 0, so existing are unaffected. New add cube map upload creates a, so as you can see it's gonna use our uploader struct, which is nice, very efficient. Creates a cube texture, type cube, usage sampler register, 1 texture record per face with layer 0 to 5. Registers 1 texture record per face, okay. And new add skybox texture uploader, loads via core image BMP, new imports, converts each from RGB 3CH. BMP always decodes to 3 channels. Wait a second, what? New import converts each from RGB 3 channels, always decodes to 3 channels to RGB H. I see, then calls add cube map upload, mirrors the existing add image texture pattern. Append optional params. Gotcha. At the end, defaults preserve the current behavior used by the skybox pipeline to disable depth writes. Makes sense. And then we got like a mixed skybox pipeline. Vertex, skybox vert, 1 uniform buffer in the fragment. Vertex input, single flow 3 slot. Depth test, depth writes off. The mesh, 24 vec3 verts, cube essentially, plus 36 indices. Copied from the C example, build with new mesh, mem slide to bytes, and reuse bind mesh draw indexed. Lovely. And resources, add skybox pipeline, skybox mesh, skybox texture, skybox sampler. So this would also give us a little bit of an edge case for our framework to handle, so we could design our framework much better. Create in main alongside the terrain mesh, add matching differ releases, draw after MSAA begin passed, first bind, skybox pipeline plus mesh plus texture sampler, push view proj with the translation com zeroed. Okay, so we remove the camera translation essentially, because like, you know, the cube map should stay centered no matter where the camera is. So the cube stays centered on the camera, draw 36 indices, terrain then draws over it as normal. Orbit camera shows a proper cube map skybox with a rotating texture in front. Enter the existing MSAA8 depth setup. Or use the plain color cube generation from the C example instead of the BMP. Go ahead, let's see what it's gonna do. Obviously I'm using Git right here, so currently we have no changes or edits, shall I say, which is nice. Let's see. Now implementing first. Framework Odin extends creates graphics pipeline. Cool. Now the uploader layer support. Sick. 666. Alright, let's go back into that stuff. Now add the cube map, upload helpers and BMP imports. And there you go. Now main Odin adds skybox mesh data pipeline. There you go. Now update the resource struct. Pretty sick stuff. Now add make skybox pipeline and wire everything into main. Alright, so that works. That's pretty cool. And it had some errors, obviously. And boom! But that's weird, man. What the hell? Bro. What? Let's see. Well, that should be way bigger. And it's just debugging itself using GTB here. The crash is in teardown. Why it keeps testing multiple times? Weird. Bro, what? Let me just try myself and let's see if there's any crash. And there's no crash, but obviously this is not the skybox that I expected. So let's see. it works fine, but the skybox is so small I could see it from outside. And why are you showing textures that is not a sky? I mean, what does the original C code does? Does it load BMPs? I think if I remember, like the original code actually had like a compute shader for the sky, not BMPs. So that's weird. Anyways, so we got like build chunk mesh. It clears the existing verts and indices array, and then half. So grid size -1 times 0.5. Okay, for wait, skybox is positioned at the world origin instead of. Hello, Masin Muha 6858. Welcome to live stream. Welcome, welcome. What are we coding over here? Pretty much a voxel game using SDL3 GPU and SDL and Odin. Right. Currently we're working on a skybox. Did zero the last column, but the ratio rose. And confirm what? Okay, allow always, confirm. It didn't answer. So no shader code for now. We already have shaders ready. We have got them from the what is it called? The C examples of SDL3 GPU. So we don't have to worry about that part. Because like debugging an issue in both the Odin side and the shader side would be a mess. So at least we're sure that the shader side is perfect. So we could focus on the Odin side, at least for now. Though later on I would like to hopefully translate those shaders into slang and use slang instead of GLSL. But yeah. Both issues are now clear. What BMPs actually contain, confirm the fix is the correct fix. Now let's see, actually contain. Wait, what the heck? Bro. Bro. What it did. Sounds good. I thought SDL GPU didn't support shaders, to be honest. The more you know. No, SDL3 GPU is like one of the best cross-platform APIs. Like the closest you can get is WebGPU. So like either WGPU in Rust or Dawn. That is the like the browser Chromium implementation, like the C++ implementation of the WebGPU API. And you got here SDL3 GPU, which also supports you know, Metal. It supports DirectX and Vulkan, pretty much. And so you just like have this kind of like the only thing that it doesn't support, at least for now currently, is web, but doesn't matter to me personally for now. But yeah, so basically you just call like into SDL3 code, and then depending on which backend it's currently on, it kind of translates your calls into the backend that it's using currently in this platform. In this case, we are on Linux, so it's probably using the Vulkan backend. But the other one should work too, in theory at least. But yeah. Now remove the unused BMP import. I'm not sure, I didn't follow through what it was doing here. Oh, okay. That's interesting. Wait, where the heck? It's trying to get a screenshot, interestingly, here. I'm just curious, like, what it's doing. I don't think it would allow it because this is Wayland. Like, security doesn't. Yeah. I see. But it was kind of clever. So like it wrote some code in like Odin at some point, right? Hold on, let me find it. There you go. It wants eyes, yeah. it can't support vision. This free model at least, but in open code. So is the correct fix? Now let me see what the BMPs actually contain. So you see it kind of wrote some like temporary like Odin code, which was kind of clever, and then it kind of just sampled some pixels from the from the images using Odin, and like it compiled very quickly, or I don't know, it erred here, I think. Yeah, and then it kind of repeated, and there you go. It's crazy. Anyway, let me test what's going on here because this looks strange. I mean, what the heck is going on here? All right. So, let's see what kind of shaders we have. In fact, here we got. Where's the sky shader? Do we have a sky shader here? Sky shader, skybox, vert and skybox frag. So are these like using some kind of like textures, or are they generating? Yeah, they're using texture cube. So right, let's see what it kind of was working on here. Right. So M30 did 0 to lax. So what kind of images it's actually using for the cube map, in fact, for the skybox? Skybox texture. Wait, is it like hard coding them, or where the heck it's getting the path? Really? Where's the path? Huh? I believe it's probably like hard coding them though. Bro, what? Which textures are you using? And where is its path? I usually find it easy to just read the git diff rather than... Yeah, actually that's a good idea. I mean, I could just read it here, yeah, true. I forgot about that. So we edit this into the framework and add a cube map upload. And you actually give it some cube map face data, which I guess continues probably the data bytes of the textures, I would guess. And then it calls create texture. And then it uses the upload record, and it grabs the data from the faces ID. So okay, so the cube map face data. All right, sky direction, sky color, and add skybox texture. Uploader. Okay, but where is the actual data coming from? Hold on. So we got the vertices here. Got the pipeline, the mesh texture, and sampler. And here we got, I usually find it, okay. Let's see here what's going on. So skybox transform, camera view projection, and then it zeroes out the translation. Then it binds the pipeline, it binds the mesh. Then the GPU fragment sampler, which you got from these textures and samplers. Then it draws indexed And then it pushes the skybox transform. Make skybox pipeline. Alright. Skybox mesh. Bro, what in the world? Where is the actual data? Okay, hold on, let me just see what it said here. What? It's using armadillo? Really? What the hell? Really? Where app generated procedurally in memory. Oh. What? Builds a 64x64 gradient Skyper face? Hello, man 3D, welcome to livestream. So it's probably just generating them in add skybox texture. But what the hell, bro? Add skybox texture. Where's add skybox texture? There you go. Okay, so it's just generating them in the CPU. I mean, is there no, like, what the hell? Is there no sky textures? What the C example is using though? That's kind of weird. I don't understand why it kind of just generated them. I was like, what the hell? Where is getting the textures from? I mean, we could actually see here, like images. We got a few images here. We got ravioli and we got cube BMP. Oh, what the hell? What? So this is the skybox structure. Really? I see. So interesting. So it's just an example for cube maps, not literally like sky, which is interesting. Weird. Let's see what's up. No, the project has no actual sky textures, only contain test assets. Cube map, the one you referenced, no image files at all. Creates a 64 by 64 cube map and clears it through the via render pass. So neither C example renders a sky. So there's no sky example? What? I mean, there is a sky. What? But there's a sky shader. Which example is using it? Which C example? Oh, so like it just generates them. It just isn't a skybox just a cube but faces render inward? Yes, it is. I was just kind of confused that there was no actual sky textures. It was apparently the examples wasn't using like real sky textures. I think is black cube. Lloyd's into. But I can still see the skybox from outside. Maybe it's too small. Or I don't know. Or maybe the actual translation thing is not working. High procedural gradient fill is currently the only thing that produces. Okay, so let's see. Let's just put this here, I guess, or something. Yeah, it kind of hides that. Alright, so let's just do this manually. This is the kind of times I should have been using what is it called? But anyways, I don't even remember its name. Well, hold on. Alright, let's actually run this now. Odin run. Yeah, so like the problem is that it's not, the camera is not inside the skybox, it's looking outside. Okay. It's probably the actual, like, I don't know, we'll see. What? Really? Hell no, what? I am running from the current source. Bro, what? Or, you know what, how about we remove the actual build folder? Where's the build folder in Odin though? Bro. Wait. Where's the build folder in Odin? Oh, it's hidden, I guess. Wait, what? Okay, I didn't realize that until now. Straight to a single where out says... Well, I'm building the current source, but the skybox is not centered around the camera. I thought it was like maybe a caching issue or something, so I wanted to just remove the build folder, but apparently Odin doesn't have a build folder in the first place. Yeah, Odin's honestly an amazing language to work with. A lot of things just are simple. Yeah, pretty much. I see. Now the real question is, what the hell is happening here? Add skybox texture. So right now I think it's just like a transform issue, probably. Yeah, it's probably some sort of transform issue. Minecraft clone with SDL 3 GPU in Odin time? Yep, exactly. Alright, so we're kinda stuck with a skybox now. I mean, if it doesn't work, we could just like revert it, nothing crazy, but we kinda got there. It's just there's some problem probably in the skybox transform stuff. Okay, what happens if I... hold on. What happens if I just remove this entirely? Nothing happens. So this actually returns a mat4. A mat4 is a matrix 4 for F32. So here it's setting the third axis. I mean, the third axis is, one option if you'd like, is blow the scale to an insane number. The thing is, I'm not sure how to handle like Odin matrices, like what kind of functions it has. The compiled shaders match the source and correct. XYZ translation. Linux, all you need to handle the math. Wait, I'm kind of confused here. Yeah, it just looks like a box enclosing. Hold on. Well, I guess if it doesn't work, we could just like revert all of this and work on something else. It would be cool if we get this working. I wonder what that camera view proj actually does exactly. I mean, it's grabbing the camera. Cam.target. It's doing compaction now. Well, that sucks. Mouse button up. Anyway, let's, I guess, verify the other code for now while it's working on the fix, because this is not very interesting. Let's just verify the actual terrain code for now. So we got build chunk mesh, and it clears the vertices and the indices. And then it grabs the half size, I guess, grid size, -1 times 0.5. And then it goes through like in a 3-dimensional loop, obviously, to visit all the blocks in the chunk. If that particular block is false, then we just continue. We ignore that block. We don't do anything. Otherwise, we use linalg vic3. We basically construct a vic3 of x, y, and z. And it needs F32s, but like what we have here exactly, yeah, we have an integer, I think, or something like that. Okay, minus minus the center of the chunk, so it loads at the center essentially. Okay, that's the origin. Now for every face in the cube faces, and basically cube faces is just like an array here. We got a normal for each face, the vertices of that face, and the UVs of that face. Okay. Now let's go back to where we were actually using this. Okay, so for each cube face, we grab the normal x. So x plus the face dot normal x, okay. And the normal y is y plus the face normal y and the z. The current source looks correct. I feel like it might be stuck in some sort of a freaking loop, to be honest with you. Honestly, you know what? Let me do something. Open code. And let's just start a new. Read the code. Start a new session to simply. Or we could also ask Gemini. Read the coders what this project is. Okay. Why the sky box isn't centered around the camera? Anyways, let's go back to this code. So if 0 is less than or equal to nx, and nx is less than the grid size, I mean, whichever, do it. Yeah, I really felt like the previous session it was kind of like stuck up in some thought loop or whichever. But right now, as you can see, when I switched, I think it got the issue possibly. And there you go. Look at that. But there's this little weird thing right there, which I'm not sure what it is. Yeah, that's strange. What the hell? How do you even describe this? So it works now, but there are some artifacts. In the sky shader, I mean in the sky textures in some parts for some reason. But yeah, as you can see, like if the AI is stuck up in some thought loop, it just like doesn't want to change its mind and re-verify its logic. You just start a new session and you call it a day and boom, done. But now we still have this weird issue, which I'm not sure where it's coming from. But anyways, let's see what's next. So alright, so we were here. We got nx and y and z. And here we're checking if nx is greater than or equal to 0 and nx. Okay, so basically if it's in range, I guess. Is that the case here? Yeah. And chunk, okay. So if that thing is in range and there is a block there, then we continue. Honestly, this kind of like order confuses me. I'm used to like nx greater than or equal to 0 instead of 0 less than or equal to nx. But anyways, alright, and then we got some start, u16 length of vertices. Now for v, in 0 to 4, we append the verts Vertex pause is equal to origin plus base dot verts. Wait, what's going on here? When a 90-degree phase fills the 45 FOV, probably. Sky is a smooth gradient quantized to 8 bits and 65 milliamperes in the smooth zenith horizon in the glow fall off. Hard clamp ring around the sun. No, probably the first one. I also verified the phase order UV direction against the D3D cube map convention. Those are so it's not a mirrored rotated fixed bug. Yeah, it seems across the sky probably. Well, yeah, it's kind of like posterization. Well, not really. Damn. damn. Like, how the hell do you describe that? You know what? Let me ask the AI to describe that. Let's see. Where's that big seam though? There was like a bigger seam somewhere. Wait, what the hell? Weird. There's like a small gradient in the corner. Yeah, and how do you confirm? A good trick though is to take an SS and then send it to Gemini or GPT to try and understand what the issue is, then come back to the agent. Yeah, honestly that's a good idea. Hold on. That's a good idea. So let's go to Gemini. And let's say Odin run. And let's just grab that code, and obviously also the framework code, or I could also just SS as in screenshot of the render. I see. So let's just grab this too. There is that gradient band in the sky for some reason. Wait, I'll give you the framework code too. Don't answer yet. Yeah, okay, there you go. Okay. So that's what's going on. So it's basically a texture UV problem. Yeah, it's using just a 64 by 64 texture for the sky, interestingly. Ensure vertical alignment in sky shader. Let me look at how currently work. Armadillo? What the hell? Bro, what? Let me just give it the response. Yeah, I think I'll probably just revert the sky stuff and just focus on some other feature for now. For now. Wait, hold on, let me grab the... Oh man, the formatting stuff too. Anyways. Yeah, it's taking years, my god. Alright. You know what, this is taking years, so I guess maybe I'm not gonna use the agent anymore. Just use like Gemini myself. Yeah, that sucks, but anyways. Alright, so texel alignment 0 to 1 texel centers in the framework essentially. Alright, so let's go to framework and add skybox texture. So for every face we're making an array of bytes of this particular size, which is by default to 64 times 4 using the context allocator. Then we're going through every single pixel, then we're grabbing the sky direction and so on. Well, first of all, let's kind of so what that function is called again? Add skybox texture. Okay, so uploader comma the size, let's say, I don't know, 1024 maybe. Let's try that. And core dump, bro, what? So okay, I'm kind of confused here. So this worked, but doing this core dumped. Wait, now it's not core dumped, now it's a black sky. What? For y, 0 to size. For x in 0 to size. Sky direction, sky color. Bro. Why increasing the resolution either results in core dumped or black sky? What? This is on the stack? What? This is weird. You pass faces data into upload, however faces goes out of scope after add skybox texture returns is eventually called. Make sure the uploaded pixel data stays valid until upload finishes. The error is from the return and cube map upload. Oh wait, what the hell it's doing here? Is it like this one? Is it because it's... Bro, really? What in the world, man? What the hell? Really? So it's just like allocating these faces here for whichever freaking reason. Yeah, I see. So how are we gonna deal with this then? It needs to like live longer. Generates a procedural grand sky. Why the sky is black? Sky partial fix. The issues were reading memory that should have been uploaded to GPU and technically no longer needed. I see what's the problem. I'm just kind of not sure yet how to go about this because I didn't write this code. But basically the issue is we're currently like allocating this data here inside of this add skybox texture, and then once it's out of the scope we delete all that data, and then the upload is still referencing that data that is now unallocated. That's why we've seen those seams. So it's probably not a UV texture thing, probably. But yeah. Then make sure to clone the face into. So in fact, how the heck do we, like, we could just. But yeah, let's just see what's up. I mean, we should go read what the upload is doing. The fur won't run until after the upload. No, my uploader basically doesn't like copy the data. It just like borrows it essentially until I actually call the upload. I'm doing this because I'm like, essentially instead of like, for example, uploading the mesh data and then uploading the texture and then uploading the every single skybox texture separately, I'm basically batching them. And the way I'm batching them, instead of like copying the bytes into the uploader scratch buffer, I'm just like keeping track of the reference or the pointer to the data until the actual upload happens. That's why. So basically the upload, this data should live as much as yeah, lifetime issue. Yep. But yeah. All right, so where we were, right, let's just grab this thing right here. And let's come here, do it here, I think. There you go. Cannot assign two faces. I guess you're supposed to do this, right? Yeah. And I guess you could just do that. And next. Now we're just like passing those faces, I think. Obviously a pointer to it. And there you go. Now it works. So it's pretty much just a lifetime issue. So yeah, and here we even got like this delete verts and delete indices, which is interesting. But yeah, anyways, so that works now. That was wild. Clean sky untouched by pollution. Right, so that was insane. That was quite insane. Quite insane. Alright. I just moved the face data outside of the outside of the function of the add. Wait, what is it called again? Add skybox texture, because we need it to live until the data is uploaded. But anyways, so this is the sky pretty much. Now let's see if OpenCode would work now, hopefully, because otherwise we'll have to write this on our own. Let's see. Wait, no, that doesn't work there. Let me just grab a terminal and let's run OpenCode again. And oh, hold on a second, what the hell? Go inside of projects, SDL, GPU Odin, and OpenCode. It saves a lot of time when it works, but when it doesn't, it just makes a mess. Oh crap. That's the problem of vibe coding. But anyways, read the code. Well, that's weird. Read the code. There you go. Anyways. So now what we're gonna work on, I think let's probably work on DDD maybe, or what is it called? Like, wait, forgot what it's called. But yeah, this is getting. Wait, there you go. Right. Plan out how you'll implement block destruction, like block destroy through click. Raycast from camera. Get the camera ray. DDA, yeah. I called it DDD. DDA, okay. Simple line point check won't work cleanly across grid boundaries. Instead, use the 3D digital differential analyzer algorithm commonly used in Minecraft engine clones. It steps through grid cells one by one until it hits a solid block or reaches a max distance. So, yeah. I'm not sure, like off camera, OpenCode is so damn fast. But like when it comes to the live stream, it's just flaky, so damn flaky. It's weird. But anyways. Alright, anyway, let's see. Raycast hit, raycast chunk, ray max distance, because chunk vertices are centered. Right. Probably peak hour usage. I don't think, like, I don't know. Always, like, even at this time when I'm using it alone, it's pretty fast, pretty good. But when I'm using it live, it's just so damn unreliable. Like, at least, I mean, sometimes it works, sometimes it doesn't, I don't know. But anyways, handle the click and rebuild the mesh. So our current uploader isn't really designed for streaming in chunks. It's designed for just like batching multiple static data, multiple static uploads into one single upload. So we're probably gonna design a better uploader that is more dynamic, or like a ring buffer, or just extend the current one that we have. But yeah, we'll get to that I think once we get to multiple chunks. But anyways, so here destroy a block at hit. It grabs the resources, the hit. If not, the hit do return. Hit.block pause resources.chunks.blocks xyz equal false, and rebuild the dynamic CPU buffers. So we just wait, what the hell? Okay, so it just deletes. I mean, doesn't like Odin have like some sort of growable kind of array list or something, like a SCD vector? Because it seems like here just like allocating a whole array then deleting it, which is wild. Anyways, build chunk mesh and release the existing GPU buffers, upload the new mesh data. Yeah, we should probably work on that streaming first, but yeah. My god, this is so damn unreliable. Oh crap. Now the problem is when I just intend to start like coding myself and then it just suddenly works. Which is wild. Wild. Anyways, let's just grab this, okay? And let's see. So we got main. Now the problem is once I'm gonna start, it's just gonna start like, okay, it's actually in plan mode apparently. It's in plan mode, so it shouldn't do that. So we got array, which is a vec3 and a direction vec3, and then here we got like math.cosine and math.sine. I wasn't intending to code this on my own, but and there you go. As you can see, when I started trying to code it and suddenly it works. It just goes like in reverse. Oh crap. Which mouse button should destroy blocks? Right click? What the hell? No. Alright. Left click. And let's go. Finally. RG. I mean, let's just say go ahead. Slab? Ammonitides Woo 3D DDA from the entry cell. Transverse solid block. Get window size via SDL, get window size in pixels. Compute array, pick if hit. Rebuild the CPU mesh. And then reapply to GPU below. It's not using our existing uploader, which is actually good idea, but it, wait, yeah, that's good. And data moves into resources. Okay, add chunk verts, dynamic vertex index to resource and main pass chunk equal chunk. No framework odin GPU change except the camera event. Alright, so I updated the camera controls. Now main the odin, add the pick and procs after draw indexed. And here's the ray AABB and mouse ray. And then finally the actual DDA walk. And then the upload mesh. Replace the contents of a mesh, GPU buffers from CPU data. And yeah. Destroy block. So yeah, like every time there is like a click, it just does that ray marching thing, or like voxel grid intersection DDA algorithm. Then it just like mutates the data of the chunk. Then it rebuilds the mesh, like dependent on the new data, essentially, nothing fancy. And then it uploads the mesh, and it's not using our uploader because our uploader is not really meant for dynamic stuff, at least for now. But yeah, just doing the upload manually using SDL raw stuff. But we definitely should cook up some framework way of doing it that works great with the dynamic in-frame stuff. Because like our current uploader even like takes its own command buffer, in fact. But here for dynamic stuff, you definitely want to like upload that data as part of the actual frame command buffer. But anyways, the other thing it's also handling in-flight frames by basically making sure that the buffers are cycling, which is great. But anyways, so now let's see if this actually works. And no, it doesn't. Nope, it doesn't work. Doesn't work. Add some login so I can realize where is the issue, or locate the issue. Wait. It's registering the click, but although it should although the block so close, it says that it missed it. Destroying block at 359. There you go. Is a red flag. There you go. Cool. It made like a freaking like Odin code, and then it just ran it like that. And yeah, also the fact that like Odin doesn't need like a build directory and all that bullcrap. It's easily able to kind of like use it like a Python interpreter, where you just like give it the code inline and you could run it from anywhere and just works. Actually, no, it is using like a temporary file apparently, but I think it could probably do that too. But yeah, anyways. So that's pretty cool way of debugging. Found it. Has swapped infinities in its image. There you go. So just swap these values. Boom. So just like you like wrote a temporary Odin program, and the fact that Odin doesn't have like a build system really helped here, because otherwise like making a let's say for example we're using C++, making a freaking like CMake project C++ to actually grab GLM and so on is such a wild thing to do. Or like even including it inside of the current project, you have to add some stuff into the CMake, and yeah, it's just super messy. But with Odin, it's super straightforward. The math stuff is already part of the standard library. In fact, even SDL is part of the standard library, kinda. And yeah, it's just so good, man. Found and fixed the bug. All right, so now let's try it out. So something works there, but something strange going on too, all around. Yeah, I don't know what to say. Hold on, let me just do this. Yeah, for whichever reason, like, what the heck? Bro. I have no clue what the heck is going on here. Now it does destroy a block, but it's destroying the wrong block. And sometimes even destroys some skybox face for whatever reason. That's wild. Okay, so apparently it's not taking into account the model matrix. So basically the rotation of the chunk, apparently. Which is interesting. Okay, GPU buffer overflow. Bro, what? We have a buffer overrun in the GPU. That is insane. That is insane. Fix recreate, yeah. I guess we'll have to rewrite it in Rust. Because this amount of like buffer overruns is insane, man. And like even like the lifetime of the of the uploader stuff. Damn, bro. Yeah. I guess we'll have to rewrite this in Rust. You're right, the chunk is drawn with model match for rotate, but the pick happens in rotated chunk space. Let me fix by transforming. Cause yeah, and like if this was in Rust, it would have definitely not let it do that weird thing that it did. And same thing with WGPU. It would have not let it like overrun the VRAM thing, the VRAM buffer, either. But anyways, instead of writing back into fixed size buffers release, but yeah. Let's just continue this prototype anyways in Odin. Bro, this is taking years. Alright, let's see if this works now. Yeah, kind of works now, but still there's some weird buffer overruns. Yeah. It kind of works now, but there's some weird buffer overruns in the VRAM. Like the skybox, like the click destroys some skybox faces, or even some faces from the chunk that is unrelated. Read the whole code and let's see. Yep, that's true. I gotta definitely add more logs. Yeah. But let's just leave it do its thing for now, I guess. Read framework Odin. Damn, man, it's so slow. So slow. Yeah, let me just tell it to log. Add some logs to locate the issue. I wonder if this is just in the free model or is like the subscription is better than this. Like next month, like the end of this month, I'm probably gonna pay and try. But yeah, this is super frustrating. Anyways. Anyways, this is a good test to see how far you can go with vibe coding. No clue. I personally just pay for DeepSeek API directly. DeepSeek API. How much did that cost you? And is it like good? The user diagnosis of VRAM buffer overruns matches the hypothesis. I want to verify before playing the logs. Larger than before. Oh shit. It's gonna simulate the mesh-sized behavior in a Scratch program? What the hell? That's insane. I ran through a whole month once with just $2. Really? How much do you use it? And which language? Odin? Plan mode is active, so it's read only. Yeah, this is very annoying. But yeah, at the end of this month, I'll probably try to pay some service. And we'll see. Yeah, the DeepSeek API is cheap, but the model isn't that great. What do you guys use? What do you use, Theo? I think you probably told me before, but I forget a lot, man. Damn. Back then, about every night, avoid AI in Odin since it's a comfort language. I used to work my brain a bit. Run AI a lot on GSTS TypeScript. I'm tired of webmin. I see, that's understandable. The new version seems nearly as good as GPT Luna. Really? What projects are you guys working on currently? Okay, I've read the full code. I believe I found the root cause analytically. Here's my plan. Shrink the... Okay. So, since has no get buffer size, I'll track capacities in the mesh struct. Exceeds capacity. Create replacement vertex index of the new size, upload into them. Swap the mesh pointers, update capacities. Yeah. This is where Rust shines. But anyway, fix it. Already submitted. Commit buffers, same last second. Well, DeepSeek still might be better than open code free models. I don't know. I've been using Claude $20 per month, the most, but I might have to go back to DeepSeek due to the usage limits. How far can you actually go with the Claude? Like, how many times it hits the usage limit? Like, how many hours, approximately, you could use it for? I mean, the free model of like open code is like very generous limit. Like you could go probably like 2 hours to 3 hours, and then you hit the limit. The 5-hour limit is the main issue for me with Claude. Technically, OpenCode does offer DeepSeek Flash for free if you want to try it. I don't know, like OpenCode really works well with their actual model, like Big Pickle. I tried some other models here, but it just sucks ass. It really, really sucks, but we could try at some point, maybe. Like, how do you do that though? Technically, it does offer DeepSeek Flash. Where do you get the DeepSeek Flash thing? Do you like just switch the model in here, like Control Shift P, I believe, or Control P? Yeah, Control P. Then like you could switch the model. Oh, there is like DeepSeek V4 Flash, yeah. Like Kuna, North, Minicode. But yeah, last time I tried them, they didn't work. I don't know why. But yeah, let's leave it, just continue this stuff, and then we'll see about that. I'm not sure which one would be better. Because to be honest, like in Big Pickle, when it works, sometimes it works way better than even Gemini and like ChatGPT. But when it doesn't, so yeah, it's just very unreliable. Sometimes you get very good results. Sometimes you get like some very bad results. Sometimes it's very fast. Sometimes it's very slow. And I think probably because it's a free model. And obviously you hit the limit once you get into like 2 hours or 3 hours. But yeah. Alright. Maybe we could try in another terminal actually, hold on. Yeah, we could try on another terminal, hold on. I have like, for example, the... Should we try Rust? Should we try Rust too? That would be weird. Nah, for now, let's just go to projects, okay. Let's go to SDL GPU examples, right? And then let's open up open code there in that C repo. And let's just give it a few tasks, some very simple tasks. So let's switch the model to DeepSeek. Dual timing A's on a single project, that's good. Yeah. Select variant default, low, high, max. I don't know, man. Let's go with default for now. Doesn't matter, I think. And because like sometimes the actual like max thinking models just like do worse, way worse. They just overthink, I guess. Anyways, all right. So let's just tell it read the code. Let's see if it even works. Because last time I tried the other models, other than Big Pickle, they didn't even work in the first place. I mean, I could use my open, what is it called? Open router stuff too. But honestly, I had very bad results with those two. There you go. As you can see, it doesn't work for whichever reason. There you go. Okay, let's go. So it did take a little bit of time though. Yeah, I guess maybe we should use like my open router key. I mean, hold on. I guess we could do that. Hold on. Let me go to open router and grab some key, hopefully. Okay, let's see. Small note, OpenCode is being throttling with DeepSeek because there's so much usage demand. Yeah, because I'm using their API, so I'm gonna be switching to my open router key, and let's see if it's better. I'm just like logging in right now. Hold on. Where is that? How do you... There you go. Sign up. Let's go. Let's just grab a key. There you go. Now I'm gonna do Control P and connect to provider, and what is it called? Open router. Then I'm gonna give it this key, and boom, let's go. Alright, let me close this and let's go. Alright, let me bring back the screen. Okay, is everything good? Let me also bring out the chat. And yeah, there you go. So as you can see, this is still a bit like stuck in there. And this one just streaming response failed. Boom, the request queue is full. Because I think, yeah. Anyways, let's see what's up. So Control P, switch the model. And let's go with open router, I guess DeepSeek, flash free. Well, not that one. I guess flash latest or what? But these one doesn't look like they're free though. Huh. These ones are actually free, but I tried these, they didn't work before. 0731. Where's that one? Not free. Yeah, alright, so I don't have any credits currently. That sucks. GPT OSS. What? This one is free? What the hell? Yeah, that doesn't look good. Yeah, this sucks. I'm in read-only mode. And this is like just a 20 billion model, 20B. Let's try some other model, I guess. It's also quite slow. Free models router. We could go with this one, I guess. Yeah, no wonder it's being slow right now. Yeah, we should have like gauge kept open code for a while. People didn't knew it was free. I mean, I didn't knew either, but yeah. All right. I use this free models router, which basically picks whichever free model is currently available. Hopefully the best one. Just read the code. I should have, well, nah, it would Yeah, that's why I didn't use it on my Odin project, so it doesn't interfere with this AI. I'm not sure if it would, but probably. You see, it's very freaking slow, first of all. And second of all, probably crap. It's actually faster now, I don't know why. But yeah, I guess it's good to understand the limit of vibe coding, at least for free models. Okay, for example, how the skybox example, or like the cube map, or like cube textures kind of example works, for example. I mean, it kind of works, but as you can see, it's slower than a freaking like local model. Bruh. And probably not as smart either. But well, yeah, I'll stop the stream now and then it would work. Because that's exactly what happened like yesterday. I just kind of stopped the stream because it was lagging out so badly, and then boom, I got the first chunk. But yeah, wild. Life always goes in reverse. Never works as you like. Anyways. Anyways. Well, I guess maybe we should just not use like vibe coding anymore and just use Raylib with Odin. And not use an LSP either. Not use an editor, just use Sublime Text like Odin Creator. Go back to the Stone Age. And yeah, just do it. Yeah, it's insane. Because yeah, when it works, it's great, it's amazing, but when it doesn't, you are in trouble. Yeah, Gingerbell, something else. I just started to like watch his podcasts, and also the other guy that made Carl 2D engine. Yeah, I just started like I also noticed that he made his own like static site generator. And honestly, yeah, I was looking into that thing once to try to make some blog, or I don't know what it was. And I was so confused. There was just a lot of options, and every single option was super confusing. Yeah, there was also Astro and Hugo, and yeah, it's just insane. At that point, just like create your own thing. Like, it's crazy, man. Damn. Alright. Alright. At some point I was even thinking of like just quitting like low-level programming like at all, and just like using vanilla JavaScript, no TypeScript, no packages, no nothing, Like the browser APIs are just so good already. Like it contains web codecs for like video stuff or video decoding, hardware accelerated even. Like, you know, getting hardware accelerated video decoding to work with graphics is just insane. Like using FFmpeg and like natively, because there's just a lot of bull crap that you have to handle, like multiple codecs in every single platform that is hardware based and all sorts of weird stuff. But in web it's pretty smooth. Like you got the web codecs, you got web GPU API, you got all those APIs, and yeah, like even if you want, let's say, some sort of you know, transferring files over the, like videos over the network, something, you could just use WebRTC. Trying to use WebRTC, like for example, like natively is just insane. Same thing with like capturing the freaking window. Like you gotta handle Wayland bullcrap, you gotta handle Windows APIs for capturing the window. But like in web, you actually have an API to just do that. Like, damn, like, it just works. It also works with web GPU, and it works with web codecs. So the only thing you gotta have, or you gotta need from a library, is like a muxer and a demuxer. So, cause like web codecs only handles like the hardware decoding and encoding for you, I think. But you still need something to read that MP4 container or WebP container or whichever your extension is, because the container is different from the thing. And I actually found a pretty good library for that. In fact, I did actually kind of vibe coded like a video editor once. I kind of failed horribly actually, to some degree. At the end of it, when I started to go through like more advanced stuff, like what is it called, like timeline, UI, and so on. Yeah, there was just like some sort of memory hog, like memory leak probably for HTML elements, like creating and recreating HTML elements, etc. I'm not sure if it would be better with React, probably. But yeah, yeah, it was just wild. Like I'm just literally trying this like AI vibe coding stuff on every single language and just seeing what sticks. And yeah, it just allows you to really easily like prototype stuff, which is very nice. Honestly, AI is best as a co-pilot, keep track of things and give tasks that are limited in scope with a detailed implementation path. Letting the machine think is no bueno. Yeah, for real. Yeah, I think the best combination is like you have already wrote the code, right? But right now you're just rewriting it. Like for example, with the SDL 3 GPU boilerplate that I've already like wrote myself, it was very easy. I could just like myself guide the AI to do the best thing. But when it was time for like the actual voxel stuff, which I have little experience in writing myself, that's where trouble happened, right? But yeah, anyways, so apparently it seems like it's done. Hopefully my yapping session was fine. Anyway, so done. Root cause was a fixed size GPU buffer. Destroying an interior block with greater than 3 solid neighbors yields a rebuild. Was a fixed, okay, then the issue also applied road out of bounds to clobber the adjacent skybox buffers, bruh. Changes. Let me just try and see if it works. So far so good, I guess, but now let's see. And I mean, at least it's not destroying the skybox anymore. And it kind of got it. Yeah, it did. But you know, sometimes it does kind of miss it though. Sometimes it does miss, I'm not sure why. Yeah, as you can see, sometimes it does offset a bit. It could be that like weird thing that we had earlier with Rust voxel implementation, where it was like doing the voxel DDA in an aligned mode. So yeah, now it works. but there's a little offset from time to time. I'm not sure if it is an alignment issue between rendering and the DDA. Like for example, one using the top, the corner of the block as reference, while another is using the center. Because this is something that happened to me with you know, doing this in Rust, or the model matrix is skewing stuff. Yeah, I don't think model matrix, but honestly, let me just tell it only that part, right? Well, another is in the center or something. Anyways, let's just see what it's gonna do now. Though, hold on, commit first. Wait a second. What we were even doing here, I don't know, fix destroy block. Yes, commit, and let's go. So now we're just gonna revert and done. Alright, so what I was talking about, yeah, I was talking about the JavaScript library to mux and demux videos. I think it was like GS Bunny video. I have a very big issue with remembering stuff. There you go, Media Bunny. I have a fuzzy search in my in my memory at this point. Media Bunny Complete Media Toolkit. A JavaScript library for reading, writing, and converting video and audio files directly in the browser and faster than anybody else. Now, the first thing that I kind of noticed that it said in here, like down here, like it supports all of these extensions, and it said that it was way faster than FFmpeg WASM. And I was like, what the hell? How could a freaking like TypeScript or JavaScript library like outperform FFmpeg? But then I remembered that the FFmpeg WASM here is not using hardware acceleration because it can't. You know, WASM is sandboxed. You know, that's the first thing. So it's just using like CPU, like just CPU, just software decoding, and demuxing, not like GPU decoding or whatever. And even that, it's probably very limited, like just one thread or whatever. And also another problem is that it's actually working in the browsers. Like it's just bytecode that is interpreted by the browser, not literally like native FFmpeg, you know. But apparently this was way faster, as you can see, than FFmpeg WASM. And that was the case because, yeah, as you said, it was compiled into the browser, first of all. And second of all, it was using web codecs, like the new, well, the kind of new web codecs API that is hardware accelerated video decoding in the browser. And yeah, it got all of this just in JavaScript and TypeScript. But yeah, so it was another thing that I found very interesting about like using JavaScript like browser APIs was the OPFS, I think it was called. OPFS, I think, is it? Yeah, probably. So what this kind of allows you essentially is that you kind of like create a virtual file system inside of the browser, right? And then you could use that virtual file system to, let's say, you know, write videos into it, read videos from it, and to basically show the user a file system, kind of. So they basically have their own like video editor files, and it's very fast. It's like you know, a regular file system. So it's way faster, obviously, than SQLite and stuff. And yeah, that was a very interesting like experiment, and I vibe coded the whole thing. The only thing I had to know is which APIs to use. Like, I've heard of OPFS. I'm not sure where I've heard of it exactly, but I was kind of like researching about it essentially, like the new browser APIs. And yeah, and I just used that. And then I also, through the AI itself too, I found Media Bunny, and it just worked pretty much. But yeah, it was pretty interesting. Maybe someday I should like stream JavaScript again, like trying to recreate like a video editor thing, and then using these APIs. But yeah, if anybody's interested to see that, let me know in the comments. But anyways, all right. So I think so fixed the DDA grid was offset by half a cell. Yeah, there you go. It made the same issue that it did when we were vibe coding a voxel engine in Rust, where like the DDA grid was offset from the actual rendered like blocks, which is insane, right? But right now I think it would be perfect. I'm not sure how good is the implementation currently, but yeah, it seems to pretty much work. And since we're even taking account the model matrix of the chunk, like even like rotating chunks doesn't really matter. It just works because it's already canceling the model matrix itself. And yeah, right now the block destruction is just working great. Now I guess we could tell it to commit this, and we can finally continue. Oh man, that was insane. That was insane. But it's nice when it actually works. There you go. So it works perfectly. Alright, so now we're going to tell it to add blocks. Git commit and add blocks. And yeah. Alright, so yeah, that was quite interesting. And what does add blocks mean here? Place blocks feature, commit the current fixes. Yeah, just get add the changes, both the placement and commit. No, this, okay. But yeah, that was interesting. It was very interesting. There's even like some actual like new APIs like WebNN, like neural networks in the browser, like an API in the browser for that too. So that's just insane. I don't know. I think it's only like implemented in Edge probably currently, and you probably need some extra things to do, like maybe add some flags or whatever. But it's insane. It could like use the GPU or even an NPU. I'm not sure if there's like, you know, the current hardware, if there's any laptops that have NPUs currently. But yeah. Alright, now place blocks feature. Yeah, that's the thing Chrome is trying to force. Yeah, it's pretty interesting. So I'm just like, that's why I was thinking about like moving to just like raw JavaScript, because I was just so burnt out of all the boilerplate code I have to do in like other language, like native languages, just to get a window on the screen, like with a proper surface and so on. But yeah, and I was just like seeing this, wait, okay, I guess maybe it's added it now. And yeah, I was literally thinking just moving to vanilla JavaScript at that point. But I don't know, we'll see about later. So Odin is kind of fun. I'm trying Odin right now, although I'm honestly not like writing the code, I'm just like vibe coding it. But yeah, alright, so committed. Though honestly, if I write the code myself, I'll probably not use SDL GPU, to be honest, because it's just too much trouble to get the boilerplate going on. I'd rather even like go ahead and like just freaking implement a Vulkan render instead of dealing with like SDL3 GPU boilerplate, like the cross-platform shaders stuff and so on. It just sucks to write. So, but yeah. So I'll probably just use Raylib if I rewrote this by hand at this point. But yeah, and there you go. Like placing blocks also works perfectly. But wait, I guess once you once you get out the chunk, obviously you're limited. Now we gotta work on like the stream of the chunks, right? So yeah, all right, so git commit, then generate chunks around the camera. Yeah, let's not just philosophize stuff. Let's just tell it exactly what it needs to do, and then we could iterate later on. I'm not sure how the code looks like currently. So we got here the array hip. Wait. How should generate chunks around the camera work? Multi-chunk grid, and one chunk follows camera. Keep a single active bed, relocate, regenerated to follow the cameras. Well, peeps, it's 3 a.m. Yeah, goodbye, Massine. Well, thank you so much for coming in. Alright, so we got... So it's probably multi-chunk grid, yeah? There you go, let's go. And let's see if this would work. Yeah. I was also looking into like the Odin ecosystem. Odin. So honestly, I think if like vibe coding worked properly, what every program would essentially do, there will be no coding. Like you would just need to know how to use like debugging tools and how to use like which libraries does which and how they work in like as a foundation. So like if I were to like, you know, advise someone that is new to programming, I would definitely tell them to not use AI, at least at first, until they learn like the foundations. And also for the foundations, I'd probably just tell them to just focus on HTML, CSS, and JavaScript. And that's kind of controversial, right? And just vanilla JavaScript, no TypeScript bullcrap, no npm, none of that. Just HTML, CSS, and JavaScript. Because that alone, and obviously the browser APIs, that alone really keeps you away from the distractions of like multiple languages and libraries and all that crap. And yeah, it just lets you focus on the actual job. Like, here's your canvas, draw into the screen, here's an array, do this, here's an HTML element, and that skill would like, you know, serve you in whichever ways you want, like whether it's, you know, hobby coding or, you know, a job or whichever. So yeah, and then later on they could decide whichever they want to go into once they have like enough, like they got a job or like some way to like fund themselves. Because like at least for myself, I've just gone straight, you know, from Roblox. I did got some success on that, like financially speaking, but then when I moved to native, like all of that have gone into the window. Right? So, and yeah, I've just gone like into what can I say, a loop of trying this and like dealing with CMake and dealing with C++, C, like multiple languages and multiple libraries, and each thing have its own stuff. Like, yeah, and like the thing is, once you get inside of this kind of like native stuff, you can't really get out of it. Like trying to program regularly, like a regular person, like without going low level, just feels so shallow. Um, like using Raylib, or like not Raylib actually, to be honest, but like yeah, using the other kind of technologies like languages and so on. But yeah, I should probably make a video honestly about that. I just don't get like the time. Like I don't know, like just record a video and start talking about. Yeah, those videos actually works very great. But yeah. Anyways, so what this was working on? Oh yeah, chunks, multiple chunks. I see. Well, that's interesting. Okay, back. Though, do you like the render distance is so damn small. I'm not sure what it's using though. It did say that it's probably using some kind of ring or something, which is interesting. That's the efficient way of doing it, if that's really the case. But we'll see. Oh man, that was so fast. Yeah, I'm not sure how it handled this. It added the chunk and chunk grid coordinates for every chunk. And then right now it calculates some base position of the chunk, like for the blocks, because you need to offset the blocks per chunk obviously. And let's see. Oh man. That was so fast. Anyways, rebuild the chunk mesh. And deployed it to the GPU buffers. I think it probably works. Hold on. Bro, that was fast. It's just because I'm moving the camera, I think. Is that the issue? A phantom in the program? It's probably that's what it's trying to debug. It's seen like churn of meshes. And yeah, I guess that works. Wait. Yeah, that works. Nice. It actually works, but the render distance is too small. Commit first. Okay, update the chunks. The churn was real, the camera moving. Let me strip the debug, then commit. The churn was real. So like, I was just moving the damn camera while it was running its test. It was like, bro, the churn. What the heck, man? It was just like me, phantom in the damn machine, just moving the camera. And it's uncertain where the you know, it's like someone like it's like, you know, running your program and suddenly the camera moves by itself. That's what it's like to the AI. So yeah. All right, let's see. Well, one weird thing is that there are probably blocks on the sky though, isn't it? I mean, that's good and bad at the same time. The bad is the fact that some of it is like, you know, just hanging in the air. The good though is that we actually have 3D overhangs and so on, not just a blend height map. But yeah, right now it should actually like change the camera controls to like, you know, free camera. But yeah, I'm not sure what it's using here to do. The chunk streaming? To evict. Yeah, I see. So it's probably not doing anything crazy, it's just like deleting the actual chunks. Probably no like fancy pools or ring buffer uploader or whatever. Which we could actually make it do so. We could make it implement it, but yeah. Anyways. But I'm glad that this actually works now. That was quite insane. Yeah, cool. We at least got something working. Though obviously we could move a lot of this stuff into the framework, so the actual main code would be way more readable than this. And so I could hopefully like verify what the hell is going on there. Because it's very hard to like read just procedural like SDL calls. And yeah. Now it's changing the camera controls. Chunk blocks. So it's had some trouble with compound literals or whichever. Bro, what? The camera was moving by itself. What the hell? Who's the phantom now? Bro, what? Oh, is it like maybe the actual chunks or what the hell is going on here? Okay, I have a lot of questions here. I'm not moving anything right now. It's just by itself. Oh, actually, wait. No, it's just like the actual chunks rotating. And I thought it was moving. I guess. Yeah. Circular globe problem, I guess. But yeah. Remove the rotation around the chunks. I thought the camera was moving by itself. It would also simplify the math a lot. Hopefully it wouldn't break it though. Does it really like simplify the math a lot? I mean, Like if it's a good implementation, it should be just like a matrix kind of thing. But I don't know. And it's interesting that we're still using just like the shaders that came up with the examples of SDL3 GPU, which is nice. We're still not writing our own shaders, and in fact that might be a good thing to try to do that next. Okay, so it kind of works now, but the left and right translation is like inverted, and obviously the mouse is not captured, and like even the mouse, I'm not sure, it might be inverted too. Can't tell because like the mouse is in my face, so generally I need to look down in here, and yeah, no, actually it's good. I think it's just like the movement in left and right. Yeah, movement left and right is inverted. And what else? And yeah, and also make sure to capture the mouse. Oh boy, well that was crazy. But now it works. You got like kind of like a Minecraft thing in 800 lines, obviously using the framework that we created, which is like around right now like 1100 lines of code, which is mostly just like SDL3 GPU boilerplate. But yeah, in fact there's a lot more boilerplate that we could put in the framework, but that comes later. I mean, that's kind of like how I like to abstract. First of all, just like implement it inside your application. Then once you're done, you could analyze how you could abstract some pieces that could be reusable between projects, or just make creating the main application a little bit easier and more organized, essentially, and more readable. But yeah. Now it's compacting. I mean, how much time we've been streaming though? Yeah, 2 hours and a half. So it's probably we would run out of tokens very like soon, I guess. But yeah. Kinda got something working today. We implemented basically Skybox and chunk streaming, block placement, destruction. Imagine trying to do that by hand. Oh boy. Oh boy, oh boy. Just trying to understand these concepts needs its own time alone. Yeah. I kind of roughly like understand, for example, the DDA thing. But yeah, anyway. But not the specifics. I really need to rewrite that in like manually to actually internalize how the heck it actually really works. But anyway, so now it's taking a long time. And one thing that kind of struck me is Odin have like hash maps and so on. It have it like built in, which is interesting. I'm not sure what to think about that, like what to feel about it. I'm not sure if it's a good thing or a bad thing. Obviously the bad thing could be like, yeah, you don't know its exact implementation, though you could probably read its implementation in the compiler itself, but well, it's not like in the standard library where you could just like control and click. But on the other hand, the nice thing about having it built in is the fact that it could give you some more built-in stuff, like operator overloading, vectorization, and more optimizations, etc. Yeah, I'm not sure what to feel about it, to be honest. But yeah, so I think I'll probably stop the stream here. I think we have already, like, this is just a little bug fix that is left. And yeah, that was it guys for this stream. Thank you all for watching and see you in the next one. Goodbye everyone.